Hello there. In class we proved that if you have an isosceles triangle, then the base angles are congruent. And in this video we're going to prove the converse of that. If you have two angles in a triangle that are congruent, then that triangle must be isosceles. So I'll start off by drawing a picture. And I label it ABC, and I know that two angles are congruent, so for me I'll make that angle A and angle C. That's also a given. Now, I need two triangles if I'm going to do this proof. I'm trying to show that this length AB is congruent to this length BC. And I'm going to need two triangles in here somewhere. There's a number of ways of doing this, but I'm going to drop a line straight down that is perpendicular to the base AC. So there we go, and this tells me that I have 90-degree angles in there. So it looks like I have two triangles. It looks like I'm going to have this triangle here and this triangle here, and I'm going to have to show that those are congruent. So to get a visual, I'm trying to prove that this yellow triangle is congruent to the pink triangle over here. And I'm going to start listing out my given information. I know that angle A is congruent to angle C. I was told that in the beginning. So I justify that. That was one of the givens, and that establishes an angle for me. Now the next thing is that this angle ADB is 90, as is this one, CDB. And that was because that blue line going straight down is perpendicular. I chose D such that I have that 90-degree angle. And that establishes another angle for me. Now to show that these triangles are congruent, I'm going to need a side, because angle is not a congruency condition. I don't actually know that this side is the same length as this one. I drop this line down straight, but that doesn't mean that I don't get two things. I don't get 90-degree angle and a bisector, so I don't know that line's the same as that one. I also don't know that AB is congruent to BC. That's what I'm trying to prove, so I can't assume that. But this one, BD, that's shared by both of them as part of the yellow triangle, and BD is part of the pink triangle. And that gets me my final statement there. BD is of course congruent to BD. We call that the reflexive property, and that's that idea that it is shared by both of them. So I can put tick marks in there. BD is congruent to itself. This is the football unraveling. And this is enough for a congruency statement. Angle, angle, side, while not as famous as side, 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 angle, side, or angle, side, angle, is a congruency condition. So this is all going to flow into this middle part here, and I have to write out those triangles. Triangle, I'm going A to B to D, this one. So A matches with C, B, D. The order is important. I need to justify it. My congruency condition that I was using was angle, angle, side. And then this is going to flow into my conclusion. My conclusion being that AB is the same length as BC because they are corresponding parts of congruent triangles, and therefore they must also be congruent. And then I wrap things up by concluding my final statement that this triangle ABC is an isosceles triangle after all. So, if you have an isosceles triangle, then the base angles are congruent, and we showed the converse. If the base angles are congruent, then you have an isosceles triangle. Character and scholarship for life.